Hi good people, Titus here for another Unreal Engine tutorial, and in this video we're going to create a sprite-based point-and-click movement system. This was a video suggestion from a commentator who was looking for something similar to Don't Starve, a dark fantasy survival game that uses 2D characters inside a 3D world. Let's not waste any time and just jump right into it. We're going to be using the top-down template inside Unreal Engine. If I play this scene here, I think it is perfect for this because it has the a lot of the code for the movement system that Don't Starve kind of uses, where you basically just click around the map and the player will basically just go to that location. If you would like to see a separate topic on how to set up the enhanced input system, as well as the player controller and the actual character blueprint for this, maybe leave a comment down below and I can go into it a little bit more in depth. But I think starting off, we will just worry about the setting up the sprites for this prototype. So first thing I'm going to do is I'm going to create some folders. So let's go ahead and dock my container here, and I'll right click, create a new folder. The first folder I'm going to create is going to be for my flipbooks. So the way Unreal Engine does sprites is it uses a flipbook system. So you basically import your sprite sheet and then you extract the images you want to use from that sprite sheet, and then you select the images and you basically set them inside a flipbook, and then that flipbook will basically play those images across some frames per second that you would like, and you get the animation just from that. So I'm going to create two additional folders. One folder is going to be my idle, and the last folder is going to be run. I'm going to come inside the idle folder here. Now, you'll notice here that I have some sprite sheets that I downloaded from the web, specifically itch.io. You can, of course, draw or create your own, or get them from the web if you'd like. I'm going to be using a little simple character night. There's a lot of sprite sheets for this. I'm just going to be doing idle and run, just to keep this tutorial short. But the process is going to be the same if you were to do attack animations, or if you're doing a crouch, die animations, whatever you're going to do. You can follow the same steps basically. So I'm just simply going to drag my idle animation in here, and it'll automatically import the texture sheet, which is perfect. I'll go to my run folder, and then I can just simply drag my run sprite sheet in here as well, and then it'll handle the import. Now to extract the images, you have to right click, go to sprite actions, and do extract sprites. It's going to try to set an auto extraction. Most of the time this fails miserably, so I would not use it. You can see here, it looks like it does a pretty good job of selecting the images. There's some weirdness, looks like, on some of them. The bigger problem is that the images are all different sizes and shapes. So if you were to extract them like this, when you try to play the animation's going to be very jagged. It's basically not going to be animating in place. It's going to be shifting left and right and up and down, so it's going to look very weird. So I prefer to set auto to grid, and then you define the cell width and cell height based on the sprite sheet you're using. This particular one is 128 by 128. So if I put that in here, you'll see that it creates perfect little equidistant grids, little cubes across every image, and they're framed perfectly so that when I use them in a flipbook, the image will be in the appropriate spot so it'll animate properly. The number of cells, the number of cells X and Y, as well as your margins, I'm going to set this all to 0 just to basically cut up the sheet evenly. But if you needed to add any offsets for any reason, you can do that here. You shouldn't need to if you're getting it from a professional source, especially like itch.io. A lot of those sprite sheets are set up correctly, so you shouldn't have to. Once you have that done though, you basically just hit extract. It'll then pull out all the images, and then we can begin setting up our flipbooks. Now, with this particular one, I am actually going to dock it up here because there's a lot of images in here. Now, I'm only going to do left, right, up, and down just to make it simple, but you can see from this particular sprite sheet, it is 8 directional, so it has the corners as well. But I'm going to ignore those for now. So I'm going to start with right. I will select the first image, and then as I go down the chain, I basically see the first image where it looks like it goes diagonals right here, so I shift and I can select all these images here, and then I can simply just right click and create a flipbook. And then when you create a flipbook, I'm going to title this run _right, and then if I hover over that, you can see the animation looks like it is playing correctly. You can even double click it and view the image and make any adjustments. You can adjust like the keyframes that are in here. You can add additional ones. You can add a mask material or set the play rate to be something lower or higher if you want it to speed up or slow down. But I'll leave the defaults for now. So I'll just close out of this, and I think that one's pretty good. So now I'm going to repeat the process for, looks like the next one is going to be down here. And then I will find all the images until it looks like right here where he shifts kind of corner. So all these right here, and then I can right click, create a flipbook. And this one is run underscore down. So now if I hover that, that one looks correct. So then the next one would be left, which looks like the first left one is maybe right here. Just kind of going off the shield, looks like it's angled here. And then coming across, maybe right about here. And then if I right click and create a flipbook, I will call this one run underscore left. Looks like these are all 15 image animations as well. So you can see that one looks pretty good as well. And the last one is going to be top. So this one right here looks like. And then it goes to right about here. You can see I have 15 items selected. Right click, create flipbook, and we'll call this run underscore top. And then that one looks okay as well. So now I have this one selected. I can scroll up and hold control and select the other 3. So now I have 4 selected total. I'm going to simply drag these into my flipbook folder and choose move here. Now I have basically these animations separate so I can work on them or view them a little bit easier. Now we basically need to do the same thing for the idle animation, so I'll probably speed up the video here. Alright, so now going back to our dock, if we go to our flipbooks, we now have 8 animations, 4 idle, and then 4 running in the various directions. So now we basically need to set up our blueprint. Now in this particular project, if we go to maps and modes, select the game mode, we can see our default pawn is the BP underscore top down character. So if I go to my top down folder, under blueprints, we have the top down character right here. I'll double click to open that up here, and I'm going to dock it in the main window. And we can see here's the viewport. Now we're not going to be using the 3D character, so I can just select the mesh, and I can actually just clear the skeletal mesh. And then for the animation, I will tell it to use none. And that's pretty good right there. I'm going to, everything's parented to the capsule component, so I'm going to select the capsule component here. I'm going to add a new component, and you can just search for flipbook, and the component you want to add is a paper flipbook. Now with that selected, you'll notice there's a source flipbook. We can choose any of the idle ones. I'll choose idle down, and then I'm actually going to scale this up by 3, and then maybe I'll come to the right view and I will maybe drag it up so it is inside the capsule component like so. I think that looks pretty okay. Now the other issue is the spring arm and the camera that's attached. So what we'll have to do is we don't want to inherit pitch, roll, or yaw or anything. And we will reset this. I'm going to use maybe -30 on the Y, and then maybe 270 in the Z. And then I think that will get me pretty close to good. So let's go ahead and play that, and that looks okay. So now the other issue is our character is kind of spinning. What's going on here is if we go to the capsule component and actually make this visible, the movement's actually being applied to the capsule, and then everything inside the capsule is basically following around with it. So the flipbook is kind of like rotating around. So we don't want the spinning to kind of happen here. the spinning, the way this is basically running is it's using this character movement script in conjunction with a navigation bounds. So if I show the navigation, basically everything in green is where the script is basically allowing the character to move. So what we need to do is basically select the character movement script, and then all the character movement components, basically settings, are going to be in the inspector. We're looking for rotation. So somewhere in here, there should be a rotation settings, which we can see right here. And then orient rotation to, what is this, movement? So if true, rotates character towards the direction of acceleration. So we'll mark this false. And then if we move around, now we notice that the capsule component doesn't spin, but it still moves around and goes towards the right location. So that's exactly what we want. Now we just need to figure out which sprite or which flipbook to actually play when we are going a particular direction. So the way we can do that is, let's go to our event graph and let's add in our tick function. And then off tick, which plays every frame, we'll do a print string. Then we can get our capsule component, and let's come off and get a velocity. So get component velocity, I think is what it's called. Yeah, component velocity. And let's just plug this in here. So let's see what's going on. So you can see we're at 0, 0, and then if I click to the right, we can see X goes to like positive 500. If I click to the left, X goes to negative like 500. If I click above, looks like Y goes to negative 500. If I click down below, Y goes to positive 500. So that's pretty much the way our movement's going to be handled. So we're not doing anything in the Z, so we only need to focus on the X and the Y. So let's go ahead and I'll keep this on just so it's easy to see the effect. I'm just going to drag this back over here so maybe it's not so much in the way. Okay, so the first thing we can do is we can come into a branch check. And then what we need to do is we'll get our capsule component again. And then we'll get a velocity. So get component velocity. This time we're going to right click and split the structure pin. We're only concerned with the X and the Y. So we need to figure out the two states, I guess, for our first branch check. Basically, is our character moving or are they standing still? Well, we can tell if they're standing still if the X is 0 and the Y is 0, right? Because we saw that, like when we're not moving, the X is 0 and the Y is 0. If we're moving somewhere, the X and the Y is going to be some other value other than 0. So that makes sense, right? So off the X, we can just pull into an equal operator, and then same with the Y. And then we have a Boolean value. Does X equal 0? Does Y equal 0? We need to check if both of these are. So we'll do and Boolean, and then we'll plug both these pins in here. So if the X and the Y are both 0, then we are definitely standing still. So this is basically going to be our idle state. And then if it's false, this is going to be our movement state. And before we go any further, what we're also going to want to do is we need to figure out which animation state we're in or which flipbook we're playing, so we know which idle state to return to. In other words, if the character's moving or running right, when they're done running, they should be idle right? So you don't want to run right and then idle left. That doesn't make a whole lot of sense. To be able to do that, let's create a variable to actually store that. So let's create a new custom event. Actually, we'll do event begin play, because I think that is easy to do it off that. And then we can get our flipbook, and then we can pull off a function called get flipbook, and it's the one under the sprite component. And then off this return value, you can just right click and promote it to a variable, and we can call this variable our animation state or anim state. And we're going to use this variable right here to basically store which flipbook we were kind of using last. That way we'll know which idle state to return to. So let's go back into our event tick, and we can begin working on the actual idle code. So what we'll need to do is we'll need to come into another branch. So we can hold B, click in the graph, and we'll hook up our true pin up here. And then the way we need to do this is we basically need to get a reference to our animation state. So we'll do get anim. And then we can check if it's equal to one of two states. So we have 4 idle states. We have an idle top, an idle bottom, an idle left, and an idle right. I basically just need to know if this character was moving left or right, or if this character was moving up or down. I think is the easiest way to do it. And it doesn't matter which way you go. You can do top or bottom, or you can do left or right. So in this one, I'll do left or right. So I'm going to say, was the character running right? Or was the character running left? If you don't want to do it this way, you can do up, down, right? Now, what we want to check on the Boolean is we don't want to use an AND Boolean because we don't want both of these to be true. It's either or. So we can pull off into an OR Boolean. And then we'll use that for our branch check. So we're checking, was the player running left or right? If they were running left or right, then what we can do is we can grab our flipbook, and then we can tell it to set the flipbook. And then we are either going to be running left or right. So how do we tell it to check which one's which? Well, you can pull off this into a select node, and then you can set this to be a Boolean. And then you can pull in your anim state again. So this time I'm just going to hold control, drag in anim so it gets a getter. And then I can just check one value. So I can just say equal, and let's just do, this has to match what you checked here. So if you're doing top or bottom, you would check either top or bottom here. So I did right, left, so I'll just check, if it was running right. So if the character was running right, and this evaluates to true, then we should play idle right. If it is false, then we should play idle left. And we know it's going to be right or left because we evaluated that condition earlier. So basically our first condition checks as if the player is moving. Our second condition checks, was the player running left or right? And then this last check basically, if it's right, idle right. If it's not, then idle left. It's basically pretty simple. So then I can basically select this and do a Control D to duplicate it. But instead of the left or right, it's going to be top or bottom, right? So instead of checking run right, I can maybe say run top, I think is what I called it. So if the player was running top and that evaluates to true, then I should idle up. I guess I named it different things. And then if it isn't up, it should idle down. And this is kind of a quick and dirty way to cover the 4 idle states, right? And then that is pretty much good just for the idle states, actually. So we can now move into our movement states off our first false pin. So kind of the same thing. We're going to pull into a branch node, and then I'm going to move this way down here so it doesn't get in the way. Now the movement's a little bit tricky because if we look at this, we're moving if our value is either positive x, or if it's negative x, or if it's positive y, or actually in this case that's negative y, or if it's positive y. positive y is down with this, this setup. So we need to account for a lot more checks there, right? But there's an easier way we can do this. We don't really care if the value is negative or positive, right? The only thing we care about is if the x value, which let's get our component in, and then we'll get velocity. So we got component velocity. Let's right click and split it. So we don't really care if the x value is negative or positive, and we don't really care if the y value is negative or positive. We know we're moving. The only thing we really need to know is the x value either larger, is the positive x value larger than the positive y value, and is the negative x value lower than the negative y value. So a cheap and dirty way you can do that is you can use the absolute value. So we can pull off this into absolute for both the x and the y. And basically what this will do is this will ignore the sign and it will convert the value to a positive value. So if it is a negative x value, it'll be a positive x value. If it is a negative y value, it'll be a positive y value. And then you can just check that is greater than the y value. And then if it is, we know the player is moving more left or right than they are up and down. And that's really just the animation states that you need to control. Basically, you need to tell, is the player, you know, going left or right, or are they going up and down? Because that's gonna, you know, if they're going more left or right, they should play the left or right animation versus the up or down animation. Hopefully that makes sense. And then if it is true, so if the x value is greater, and we could see here, right, the x value, if the x value is larger than the y value, which it is here, they're moving right and they're moving left. If the y value is going to be greater, then they're moving up or they're moving down. So if it's true, they're moving left or right. So let's go ahead and grab our flipbook again, and we'll do like we did before, set flipbook. And then we'll plug in our true value here. And just like we did before, we can pull off this pin into a select node. And then we'll set this to be a Boolean. And then we can grab our capsule component, because remember, everything lives in the capsule component. We can get the velocity from that, or get component velocity. And then we can right click and split the structure pin. And you can probably pause the video here and think of a way of what to check. Are we checking the x? Are we checking the y? If you chose x, you are correct. So because we're moving left or right, remember that is an x value. So we just need to check if our x value is greater than 0. Because remember, if it's less than 0, they're going left. If it's more than 0, then they're going right. So we can basically plug this in here. So if this evaluates to true, then we want to play the run right. And that covers this flipbook. Now, one other thing we'll want to do off this is we want to set our animation state. So what we can do is take our animation state. This time we're going to hold the Alt key to drag a setter. And we plug this into here. Whoops, hook this up here. And then, actually, I lied. You cannot use it directly. You have to pull off into a function called getFlipbook. Choose the sprite version, and then return that flipbook into here. That way our animation state will cache the details of what we're currently in, so we can use that for our idle state later. And then off the false pin, we basically need to figure out the up or down. Because remember, if this evaluates to true, it's left or right. If it evaluates to false, the player is moving up or down. So just like before, we'll grab our flipbook, and then we will do set flipbook. And then we can pull off this pin into a select node. And this is going to be a Boolean. And And then we need to grab our capsule component, get our velocity. We can split it. And if you pause it here, maybe think of which value we need to check for the up and down. If you chose Y, you are correct. So we'll just check if the Y value is greater than 0. Now, if this evaluates to true, are we moving up or down? If Y is greater than 0, is that up or down? If I'm going up here, you can see the Y value is negative. If I go down here, you can see the Y value is positive. So this is going to be down. So we run down. And then if it's false, run, I guess I did top for that one. And then just like before, we need to set our animation state. So we'll hold Alt, drag that in here, and then we can pull off our flipbook. We can get the current flipbook using the sprite function here. Pass this in here and plug that in there. All right. And just like that, we have our movement states. So we can call this our movements. And I can maybe grab this one, move it out a bit. Comment this one out, and we'll call this our idle. And then this part right here, I'm gonna comment, move left, right. Basically this branch check is just checking, is the player, actually is the player moving, is more accurate. So we'll do moving. And then, yeah, that pretty much should complete the code. So now we can compile, save, and we can go and play this. And now if I click somewhere, anywhere in the map, you'll notice I'm moving around, although we do have an issue. I think we forgot one of the states here. So let's see, when we go left, did I forget to enter that in? Run top, run down, I did. This would be run left. Compile and save. All right, there we go. Yeah, it looks like it's working pretty good. And this is a point and click, like move around. I haven't played Don't Starve. The video I saw, it looked like the person was using the mouse. You can easily adopt this same technique using a controller, and you're just moving around using the controller input rather than a point and click. So, you know, whatever you want to do there. But all right, everyone, I think we'll cut the video here to keep it short, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching. Consider subscribing, and we'll see you on the next one.